Welcome back. The objective of this video is to do a couple application problems of composite functions. In example 11, the volume V in cubic meters of a weather balloon is given by V of r equals 4/3 pi r cubed. If the radius r is increasing at a rate of r of t equals 1/2 t cubed for times greater than 0 seconds, find the volume of V as a function of time t. So if we're looking to find the volume as a function of time, that means we need to replace r with t. So we're going to do the composite function of v, easy for me to write. We're going to do that v of r of t. So we'll have to put r of t into the v function. So v of r of t equals 4/3 pi r, so 1/2 t cubed, cubed. So we put 1/2 t cubed into our function for r, so we have 1/2 t cubed. And simplifying our function, we get 4/3 pi, 1/2 cubed is 1/8, t to the 9th, and our fractions simplify to 1/6 pi, or pi over 6, t to the 9th, and then that would be in cubic meters, or meters cubed. In example 12, we've got the number n of bacteria in a container of leftover food is stored in a refrigerator, where T is the temperature of the food in degrees Celsius and can be modeled by n of T equals 60t squared minus 140t plus 76. When the container is removed from the refrigerator, the temperature T with respect to T is 5t plus 3, where the T is our time in hours, or our lowercase t, between 0 and 3 hours. Find the composite function and explain its meaning in the context of this scenario. So let's take a look at the meaning first. The temperature depends on the time. That's our t of small t. Our temperature depends on the time, and our bacteria depends on the temperature. So we can finally say that the bacteria and leftovers, when sitting out, or the context of this is the number of bacteria in the leftovers when sitting out for 0 to 3 hours is really what our function is. And then it says find the composite function. So n of uppercase T of lowercase t is equal to 60 times 5t plus 3 squared. So we're taking this function and we're inputting it in to uppercase n of uppercase t minus 140 times 5t plus 3 plus 76. And then applying our square, we have 60 times 25t squared plus 30t plus 9. Distribute the negative 140, add the 76. Now we still need to continue to simplify. So continuing to simplify, we distribute our 60. If I fix my mistake here of my minus 280 is actually minus 420, and we get a negative 344. Finish combining our like terms, and we simplify. We get a final function of 1500t squared plus 1100t plus 140. 196. That's 1800 T and not 180 T. So that function will find the amount of bacteria in the leftovers when it's sitting out for between 0 and 3 hours. So B says find the number of bacteria present in the food after the container has been sitting out in the refrigerator for 2 hours. So what I need to find is N of 2. And our T here is the number of hours. So this is a lowercase t in our function. So it's really N of t, N of t of 2. And that equals 1500 times 2 squared plus 1100 times 2 plus 196. And that will equal 8,396 bacteria are present after 2 hours. We also can find out the temperature in the refrigerator by simply putting 2 into our second function, T of 2, and that's just 5 times 2 plus 3. So we know after 2 hours, the temperature will get down to 13 degrees in that while it's sitting outside. And that will wrap up our application problems, and we'll get some more practice with this when I see you in class.